Okay, so we are looking at section 1.3. I did skip 1.2. We'll come back to that at the end of the semester. It just kind of flows better if we do it then. 1.3 is parameters and statistics. We're going to distinguish between a parameter and a statistic. So first I need to define those for you. It's really pretty easy. A numerical measurement describing some characteristic of a population, which remember from yesterday, a population is when you have the entire group. When you have a characteristic of a population, then we're talking about a parameter. And kind of a side note on these, when you have parameters, that's usually when we're using the Greek letters. So if we wanted the mean of a population, we would use mu. A numerical measurement describing some characteristic of a sample, which remember again is when we are just representing part of the population. Like if I wanted to get a survey of all statistics students, if I did both 4th and 6th periods, then I would have the entire population. But if I just had from this particular class, then we would have a sample. That is called a statistic. And that would be using the, I guess, English letters is what we would call these. I'm going to put an X with a line over it. That's called X bar. And that is what we typically use to represent the mean of a sample. There are two types of data, a lot like with algebra where you had two types of functions. The two types of data would be discrete and continuous. If you remember in algebra, a discrete graph is one that's just got the points everywhere, like a scatter plot basically. And a continuous is where you've got the smooth line that goes through it. A discrete data is where you're talking about the number of possible values is either finite or countable. So if you are counting your data, then you've got discrete. If I wanted to count how many boys are in this class, I would just do that. I would count them. And I would be able to see at that time how many there are. So that is a discrete data. It's usually going to be whole numbers on these. It doesn't have to be, but typically it's your counting numbers. And then, of course, continuous is your infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. So these are where your fractions, your decimals, and all these are going to come in. It's going to be where you've got data that could happen between them. This is data that is measured. Okay. And I've got 4 levels of measurement. The first would be nominal. This is data that consists of names, labels, or categories only. The data cannot be arranged in an ordering scheme. We can't put it in order. We've got categories, so it's usually going to be words. Like we're going to say these are all of the blue ones. You know, we put this into a blue category, and this is an orange category, yellow category. So there's not a first, second, third. We just label it. Okay, then we've got ordinal data. Your data can be arranged in some order, but the differences between data values either cannot be determined or are meaningless. If we have twice as many apples as we do oranges, that doesn't really mean anything because your data is different, because remember we're looking at categories again. You can have interval as a level. On these, the differences between any two data values are meaningful, but there is not a natural zero starting point. And we'll talk a little bit more about this in the next few days, but when I'm talking about that your differences are meaningful, if you have twice as many of one thing in one group, then that means that you've got, if we double 2, that means you've got 4. It means something. And we've got ratio. Both your differences and ratios are meaningful. There is a natural zero starting point, which just indicates that there is 0 of an item. There's nothing of that quantity present. Okay? So the nominal and the ordinal, this is our discrete data. These are things that we've counted. Okay? Interval and ratio, that you're continuous. So those are things that you measure. So if we measure, again, to the whole idea of the differences mean something, if we're measuring something and we get that one square is half a centimeter wide, and we say, well, this other one is twice as wide, so that means it's a whole centimeter. Okay, so that it means something. When you're counting, it doesn't mean so much. All right? Your assignment is to describe data sets as either discrete or continuous. You've got one paper that has a description of a data set on it. I believe there's 66 of them. And what you're going to do is write, if that is a discrete or continuous data set, on the other paper, the table that looks like this. So number 1, I've already filled in on your paper, but I'm going to go and fill it in here, is height. So we're going to determine if height is discrete or continuous. Remember from the notes, discrete means data is counted, and continuous means data is measured. So is height counted or is it measured? That's what you're asking here. Well, height would be measured. So that makes this continuous. And then in the third column, I've got rationale. I want you to tell me why you believe that this would be continuous data. And I do want a complete sentence on this. Here I would write height is measured. Okay, and I want you to do that because there's a chance that you could have a reason that it is discrete or continuous that I hadn't thought of. So this is a way to kind of verify that and to maybe even prove me wrong. All right? So that's all you need to do. You can work with a partner if you'd like. Just don't get too noisy. And I do want you to turn this in even if you're not done before you leave class today. Have a good weekend.